Hey everyone, I'm Justin, and this is my review of Problem 3 from Web Work Homework 8. This is a second order undetermined coefficients problem. A couple of things to note for these problems: the function on the right side of the equation, the term g of x, which is cos of 2x plus sine of 2x, can be disregarded when determining the complementary function, or as you will see shortly, will be replaced with 0. For the particular solution, y sub p, we will use an educated guess based on the table provided in the notes. For this problem of undetermined coefficients, we will use the initial values of y and y prime to find values for our arbitrary constants using the general solution. So we're given the non-homogeneous differential equation, y double prime plus 4y equals cos of 2x plus sine of 2x. We set the equation equal to 0 to find the complementary solution. So y double prime plus 4y equals 0. So now we use m and rewrite the equation. M squared plus 4 equals 0. Now we solve for m. So m squared equals negative 4, subtracting 4 on both sides. We take the square root, both sides, so we find that m equals 0 plus or minus square root of negative 4. Now, the square root of any negative number is going to be an I, so we find that m equals 0 plus or minus I, we're at 4, so the square root of 4 is 2, so m equals 0 plus or minus 2i. So now, usually the form of the complementary solution in this case would be y sub c equals e to the alpha x times c1 cos of beta x plus c2 sine beta x, where m equals alpha plus or minus beta I. So, based on this, alpha is 0 according to our solution for m. So e to the 0x is 1. So all we'll get is y sub c equals c1 cos of beta is 2, so cos of 2x plus c2 sine of 2x. And that's the answer to part A, to find the complementary solution. Okay, so now part B asks us to find the form of y sub p, of the particular solution. So, usually for something in this case, we refer to g of x, and we see that there's a cos and a sine. So, our form of y sub p would be in the form of a cos of 2x plus b sine of 2x. But there's an issue here, because y sub p, this solution, is not independent from y sub c. They're the same thing because the constants are arbitrary. So in order to fix this, we need to multiply y sub p by a factor of x to whatever degree is needed. So we see that all we need to do is multiply y sub p by x to the first degree. So now our new form of y sub p, I like to factor in the x, you don't have to, is ax cos of 2x plus bx sine of 2x. So that's the answer to part B. I like to write what part is the answer for next to it, just to make things a little organized. So now for part C, we have to find the actual particular solution. And if we look back at the original differential equation, we see that we have to find the second derivative of y sub p. And we already have the original y sub p. So first we have to find the first derivative. So of this derivative of y sub p, we see that we're going to have two product rules. So for the first one, the derivative of ax is just a. So times cos 2x. And now we have to find the derivative of cos 2x. So its derivative of cos 2x is going to be, take out the 2, put it to the front, and it's a negative because it becomes negative sine. So it's really minus 2ax sine 2x. So now we have to do the same thing for bx sine 2x. So we do that. Derivative of bx is b sine 2x. Derivative of sine 2x is 2 cos 2x. So we put the 2 in front of the bx. So we get 2bx cos 2x. Okay? So after finding the first derivative, I like to group the coefficients associated with cos 2x and group the coefficients associated with sine 2x. So let's do that. Let's just put b first. So for cos 2x, we have 2bx plus a times cos 2x. And then for sine, we have b minus 2ax, so plus b minus 2ax sine of 2x. That just, I feel like, makes the next derivative a little easier. So I'm gonna shift this over a little bit just to have some room. So the second derivative is, again, product rule. So the derivative of this first term is 2b cos 2x. And then derivative of cos 2x was negative 2 sine 2x, so negative 2, but we're going to multiply it to this whole term. 2b plus 2bx plus a sine of 2x. Product rule again here. I'm just going to write it out. Minus 2a sine 2x. Let's see if I can fit this in. So it's going to be positive plus 2. 2b minus 2ax. Oh, close. Cos 2x. I hope that's legible. So again, let's group it. We find, looking at cos 2x, we have a 2b. Where's next? Cos 2x all the way over here. And then we have another 2b multiplying the 2 in. So we have 4b. And then we have a minus 4ax. Minus 4ax. This is for cos 2x. Plus, for sine of 2x, we have a minus 4bx. And we have a minus 2a, and then we have another minus 2a. So we have minus 4bx minus 4a times sine of 2x. Okay, so now we found the second derivative of the particular solution, and we already have the particular solution right up here. So now we have to plug it into the original differential equation. So let's do that down here. So y sub p double prime is 4b minus 4ax cos of 2x plus negative 4b x minus 4a sine 2x plus, remember there's a 4 up here, so 4 times, plug that in, ax cos 2x plus bx sine 2x. Now you could just leave this like this and just condense it. I like to write what it's set equal to, just so I don't forget. Plus sine of 2x. So now, if you look closely here, you should be able to cancel, possibly, right? So we have a minus 4ax here, and we have a 4b. Let's see if we can cancel any of those. So minus 4ax, hey, look at that. Positive 4ax. So we could cancel those terms. We have a minus 4bx over here. Let's see, we have a 4 times bx, so those could cancel. Let's see if anything else cancels. Does not look like it. So now we can write 4b cos of 2x minus 4a sine of 2x equals cos 2x plus sine of 2x. Now, in order to find the coefficients a and b, we have to set the coefficients for cos of 2x equal to each other, and then the coefficients of sine of 2x equal to each other. So for cos 2x, we have 4b. So the coefficient of cos 2x on the left side is 4b. On the right side is 1. 4b equals 1. So we could find that b equals 1/4. Circle that, because we'll use that. Then for a, we have minus 4a on the left side, and on the right side we have 1 equals 1. So a is equal to negative 1/4. Circle that, because we're going to use it. Now plugging both a and b into our original y sub p, we get the answer to part C, put that there, equals negative 1/4 x cos of 2x plus 1/4 x sine of 2x. Now you can box it because that is the answer to part C. So now, before moving on to part D, you want to find the general solution. So the general solution can be found by adding the complementary solution y sub p and the particular solution y sub c and y sub p. So we get y equals, so y sub c, remember it's up here, so y equals c1 cos of 2x plus c2 sine of 2x. Now put in the particular solution, so minus 1/4 x cos of 2x plus 1/4 x sine of 2x. So that's our general solution. We're also given the initial values for y of 0 equals 3 and y prime of 0 equals 4. So looking at that, we're going to use those two initial values to find the values of C1 and C2. So you could use the first one, y of 0 equals 3, to find one of those two constants. I like to find a derivative first, so then afterwards you can do just simple algebra, and then that's it. So let's take the derivative. So the derivative of c1 cos of 2x is going to be negative 2 c1 sine of 2x plus 2 c2 cos of 2x. And then look at that, another product rule for both of those. So now we have to do a product rule again. So the derivative of negative 1/4 x equals negative 1/4. Just multiply it by the other term. And then for cos, is remember negative sine, so negative 2 sine, the negatives cancel out, so it's positive, and 2/4 is 1/2, so plus 1/2 x sine of 2x. Then for the next one, 1/4 sine of 2x. And then derivative of sine 2x is 2 cos 2x, so it's 2 times 1/4 is 1/2, 1/2 x cos of 2x. Okay, so that's our second derivative. So now we could plug in the initial values and find c1 and c2. So let's plug in the first one. y at 0 equals, plug in 0 at all the x's, so cos of 2 times 0, so cos of 0 is 1. So we got the first term, c1. Then sine at 0 equals 0, so that term cancels out. 1/4 times 0 times cos of 2x, that's 0. 1/4 times 0, that's 0, that cancels out. So the first one, at y at 0 equals c1 equals 3. Thus, c1 equals 3. So now, for y prime at 0, we just do the same thing again. So sine at 0 is 0, cancels out. Cos at 0 is 1, so we get 2 c2. Cos at 0, again, 1, so that's minus 1/4. That has the sine is 0, or the x is 0. Sine of 0 is 0, and then 1/2 times 0 is 0 again. So all we have is 2c2 minus 1/4 equals 4. Now we add 1/4 to both sides, plus 1/4. You could either put this into a calculator, 4 plus 0.25, or you can multiply both sides over here by 4. We find that 2c2 equals, so 4 times 4 is 16 plus 1, 17/4. Divide by 2, or multiply by 1/2. Find that c2 equals 17/8. Circle that, because that is very important. Now, we can finally plug in the values of c1 and c2 into our general solution right here. So let's do that. So for our IVP, we find that y equals 3 cos of 2x plus 17/8 sine of 2x minus 1/4 x cos of 2x plus 1/4 x sine of 2x. That is our answer, our final answer for part D. Let's see, part D. Okay, so this problem wasn't overly difficult, but it's helpful because of the issue that came about from guessing the form of y sub p and needing to modify it to get a solution independent from that of the complementary solution. That's all from me, guys. Hope you liked it. Thanks.